My name is Peled. I'm a psychiatrist and a neuroscientist, and I'm trying to promote a new diagnostic approach to mental disorders. Recently I was reminded many times about two old papers that we published many years ago. We were the first to try out neural network models for psychopathology, and this idea of simulating pathology was designed to try and get insight to what kind of network disturbances in the brain could cause mental disorders. Now, recently I was reminded of that because recently we all seen Alon Musk attempt to go into robotics, and Optimus that was presented recently, a very nice advancement of technology for mimicking movements, human movements with limbs and everything. But what seems immediately important and critical is the fact that we are dealing with artificial intelligence that would be applied to this robot. So the robot, in order to be human-like, will have to have human-like brain activity, and that would be probably a simulation of AI, because AI has been developing without robots. Let's say it's a robot brain in the last years, and is used for many applications and is growing very fast. But engineers, when they want to develop an AI application, they want it to be optimal. Maybe this is the reason for the name Optimus. And they're not interested in the default disturbances, let's say, of the system. While we psychiatrists are interested in disturbances, because if we simulate a disturbance we see in the clinic, we can get some insight from AI, which is actually a model of the brain, about what could be the brain disturbance. So many years ago we did two studies. One was identifying Rorschach ink blots using a very simple AI. Actually, it was just a layered structure network with supervised training. We trained the network to identify Rorschach ink blot number 3, and it was published under this title here. And Rorschach ink blot number 3, those who are familiar, looks like this. So that people, when they see this ink blot, they actually respond to it that it is two human figures holding a basket or something like that. And people would refer to the red part near the head as maybe a hat, and in the middle there is a butterfly that flies there, which is unrelated to anything. But the human figures are constructed because there is a head figure, a body figure, and then there is like a map of Italy, which is actually the legs. And people actually see this ink blot and they interpret it as two human figures. But patients sometimes have disturbance in that. They either disintegrate the blot or they overintegrate it. Disintegration gives a response like, this is the map of Italy, the head is like a stone, the hat is like a rabbit upside down, and the body would be some kind of unidentified object. And the butterfly in the human response is ignored typically, and in the case where it is disintegrated, then it is mentioned. Another possibility is overintegration. So they see two eyes, two ears, a face, a frightening face, where the heads of the human subjects are actually eyes. So there could be either an overintegration or a disintegration in patients. So what we did, we trained the network to identify the Rorschach ink blots as normal people do. And we took Rorschach because we based it on large statistics. There is a large statistic, there are atlases that register what kind of responses people have and what kind of responses patients have. And then we started manipulating the connectivity between the network units, which are artificial units which are simulating neurons. And the connectivity between neurons can simulate neurotransmitter activity, synaptic activity, and so on. And by manipulating this connectivity, we run the system over and over again with all these type of disturbances, and we came out with interesting thing. When the system is disconnected, when there is a disconnection dynamics between the units, then the system begins to interpret the ink blot in a disturbed manner, disintegrating it. So the disintegration part was related to some kind of manipulation that we did. We actually manipulated the connectivity and the threshold function. And by combining these two, we could actually simulate metaphorically the responses of patients, both for disintegration and overintegration. Now, the link between AI, Optimus robot, and psychiatric disorders could be delineated in this way, as you know, the robot would have to identify objects in the environment. So you will have to recognize them, and you will have to do it optimally and dynamically. But there could be disturbances, and the disturbances could create a misinterpretation of the environment, false perception of the environment, which will lead to false reactions, to non-adaptable reactions, and incorrect reactions. This is what we see in our patients. So here we have this idea of optimal brain activity in the robot, AI, correct AI, and we can now start and think about mental disorders as disturbances to the AI activity in the robot, but in the humans to the real brain activity of humans. And this is the basics of further development which I'm trying to promote, which reformulates mental disorders as brain disorders and as disturbances for network connectivity, intelligent activity.